Welcome to lesson 2.3 on graphing equations of lines. Today we're going to be talking about how do you graph a line that is in slope-intercept form and standard form. And so we're going to be kind of taking a look at a couple different ways to graph lines. Before we do that though, let's get into some vocabulary. First of all, the parent function is the most basic function of any family of functions. Oops, wrong pen, sorry about that. The most basic function in a family of functions. And so when we talk about linear equations, the most basic linear equation is simply y equal x, and that would be the parent function of all linear functions. When we get into the fourth chapter in this text, we're going to start talking about parabolic functions, things like y equal x squared, and so we'll be looking at a few different types later on. But for now, the parent function is the most basic type of any function for a family of functions. The y-intercept is the y-coordinate where my line meets, the y-axis. All right, and in just a little bit here, I'll just go ahead and put this here. Eventually, that's going to be b, and I'll explain that when we get into slope-intercept form next. Slope-intercept form is y equals mx plus b, all right, and where m is the slope of the line, which we just talked about in the last lesson, and b is the y-intercept. Now, x and y is any point that's on that line. So x and y are going to be various quantities and various points that are going to satisfy this particular equation. Again, we have an equation in two variables, x and y. M and b might look like variables, but they're not variables. They're two quantities that we're going to have as we go ahead and start graphing this particular equation. All right? Standard form of a line is ax plus by equals c, where a and b are both not 0. Now, there's a reason they both can't be 0, because if they're both 0, then you get 0 is equal to a constant, because again, if you plug in 0 for a and b, you're going to get really an equation of nothing. So as long as a and b are not both 0, we're okay, and again, we'll talk more about standard form when we get there. And finally, the x-intercept, very similar to the y-intercept, is the point my graph reaches the x-axis. So the point my graph touches the x-axis. Or intersects, intercept. Again, the word intercept means where it hits or crosses that particular axis. So the x-intercept is where it crosses the x-axis, the y-intercept is where it crosses the y-axis. We don't have a special variable for the x-intercept. Again, the x-intercept is going to be some point x0, because if I'm on the x-axis, I'm not up or down, and so the y value will be 0. Similarly, for the y-intercept, that's going to be some point 0b, because in this case, if you're on the y-axis, you're going to be somewhere along here. You're not going to be left or right. You're simply going to be up or down. And so b is my y-intercept, and the x value is equal to 0. Again, we'll expand on that more in just a moment. So the parent function of linear functions, the parent function of the family of linear function is simply y equal x. It's a graph. The graph of the line y equal x is shown. And so again, the line y equal x has a slope of 1. So that means my ratio of rise over run is up 1 over 1, up 1 over 1. Another way we could do it is we could say up 1, 2, 3 over 3. And again, if my rise and run ratio is 3 to 3, that's the same thing as 1. Also, you'll notice that it crosses the y-axis at 0 because it has a y-intercept of 0. All right, and so in this case, we would say b is equal to 0 because it crosses the x-axis at 0. I'm sorry, it crosses the y-axis at 0, and the slope is 1. So this is the most basic of any linear function. All right, from there, we either alternate the slope or move the y-intercept higher or lower. But again, everything kind of comes from this parent function. All right, and so in general, a y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis, which pretty much we kind of knew that already. All right? Okay, so let's talk about using slope-intercept form. As we said before, slope-intercept form is the form y equals mx plus b. Having a little difficulty with my pen there, sorry about that. So it's the form y equals mx plus b, so this is my slope, and this is my y-intercept. All right, so the procedure is simply this. Write the equation in slope-intercept form by solving it for y. So if it has to say y equals. We can't graph a line in slope-intercept form unless it says y equals. Okay, does this sound somewhat familiar? Lesson 1.4 from chapter 1, we were solving equations that were of the form 3x plus 2y is equal to 6, and we had to solve this thing for y. We've done a little bit of that, and so we're going to now actually use that idea and use solving for y to make a graph of that particular equation. All right, so again, write it in slope-intercept form first. If it already is, then the first step is already done for us. All right, the second part of this then is to identify the y-intercept. Okay, identify the y-intercept b and use this to plot the point 0b where the line crosses the y-axis. Our next step is to identify the slope, or m, and use it to plot a second point, again recognizing that slope is the ratio of rise over run. And then finally we're going to draw a line through the 2 points. Draw a line through the 2 points to make our line. Now we should always draw a line. Whenever we draw a line, we use a straight edge. So I'm going to draw a straight line through the 2 points. Use a straight edge, use the side of your identification, use a ruler, use the side of your planner, something to that form, but use something to make a straight line. All right, so we're graphing y equals negative 3x plus 1. Step 1, the equation is already in slope-intercept form because it says y equals something times x plus b. Again, if it doesn't say that, we have to do some work first. So the first thing then is we want to identify our y-intercept. Our y-intercept is 1, or we're going to plot the point 0, 1, so we're going to start right there. From there, we're going to use that point, all right, where it crosses the y-axis, and we're going to use that point as my starting point. So this is my initial value when x is 0, y is 1, and so that's my y-intercept. The slope of the line is given as negative 3 over 2, or negative 3 over 2, like that. Now the negative can go on the top, it can go on the bottom, it totally doesn't matter which place you put it, as long as you don't put it in both. Alright, so to plot my second point, I'm going to use my ratio of rise over run, alright, and recognize the fact that I'm going to start at 0, 1, and then I'm going to be moving down 3 units. Again, why down? Because the slope is rise negative 3 and run 2. So from this point, we're going to go down 3 and we're going to run 2 places, and I'm going to connect those 2 dots right there. All right. The second point happens to be the point 2, negative 2. I could really care less about that point, but the fact is that my ratio of rise to run, we went down 3 and we went right 2. From there, we're going to go ahead and we're going to connect those 2 dots with a straight line, and I'll see how I do with my line tool here. All right. And so there is my graph of the line y equals negative 3/2 x plus 1. Now remember before I said that it doesn't matter where you put that negative sign. If I made it as 3 over negative 2, that says my rise is 3 and my run is negative 2. And so I'm just going to change my color here so you can see this. If I were to start at my y-intercept of 1 and rise 3 and run negative 2, you'll notice that I'm right on that line again. So I could have used up 3 left 2 if I wanted to, again recognizing the run was negative. Typically we put the negative in the top, but again it totally doesn't matter where we put it. Sorry, I missed a 2 back here. Hopefully you caught that. Alright, so hopefully that goes well for you. Let's take a look at a standard equation, one that's in standard form. There's one of 2 things we can do. If it's in standard form, ax plus by equals c, we can make it say y equals mx plus b first, and then we can go ahead and graph it. Although that might be a little bit challenging. Again, when you get something like 10x plus 12y equals 27, again, solving that thing for y might be a bit of a challenge. So we have a better way to do that, and that is simply to identify and write the equation in standard form, making, again, a x and y on the same side. Now, to identify the x-intercept, let's take a look at a graph here, and I'm just going to draw some random line here. All right, this point right here is my x-intercept. And this point over here is my y-intercept. And so hopefully you understand the difference between your x-intercept and your y-intercept. Obviously, the graph crossing the x-axis is my x-intercept, where it crosses the y-axis is my y-intercept. Now let's think about this point right here. In that point right there, the value of y is 0. And the reason the value of y is 0 is because I'm not up or I'm not down. Remember, when we name ordered pairs, the first number is right or left, and the second number is up or down. So the y value at the x-intercept is 0. Similarly, for the y-intercept, I'm not left or right at all. So the first number is 0, and my y-intercept is whatever my y is. Now we also call that b, so I suppose you could also call this the point 0b if you wanted to. And so let's use that to kind of go ahead and fill in our boxes here. It says identify the x-intercept by letting y equals 0 and solving for x. Use the x-intercept to plot the point where the line crosses the x-axis. Identify the y-intercept by letting x equals 0, because again, the y-intercept will happen when x equals 0. I won't be left or right at all, I'll be simply up or down. So we set x equal to 0 and we solve for y, and then use this y-intercept to plot the point where the graph crosses the y-axis. And then draw a, once again, straight line through the 2 points. Because again, all you need is 2 points to make a line. So once we've got our 2 points graphed, we should be able to connect those with a straight line. So huge difference in the two methods. So it really kind of depends on what type of equation you have. If you look at this example, this is one that's in standard form. So this is already in standard form, and I'm going to go back and kind of wipe some of this stuff out. So as you follow along with your notes, you may have to do some scribbling and erasing, but kind of bear with me as I go through this. If I want to graph the equation 2x plus 3y equals 12, step 1, it's already in standard form, so we're good there. To find the x-intercept, if you're looking at your steps from up above, to find the x-intercept, we set y equal to 0. And so this equation becomes 2x plus 3 times 0 equals 12, and 3 times 0 is going to be gone, right? 3 times 0 is just 0. So to solve this equation, again, we let y equal 0. To solve this equation, we divide both sides by 2, and so x is equal to 6. So we're going to plot the intercept at the point 6, 0. 1, 2, 3, 4, 5, 6. And there's the point 6, 0. So we've now found our x-intercept. To find our y-intercept, or b, we simply now let x equal 0. And so when x is equal to 0, we have 2 times 0, which again is going to cancel out. You're left with 3y equals 12. Dividing both sides by 3, you get y equals 4. And so we're going to plot the y-intercept, which is the point 0, 4. Our last step is to go ahead and connect those 2 dots with a straight line. And we'll kind of go like that. You guys obviously will have the benefit of a straight edge that you can lay through those 2 points. And so there's your graph of the line 2x plus 3y equals 12. All right, now you can go through the process of changing that to slope-intercept form if you want to. All right, and if you did that, you would find that you get the exact same picture. All right, so our last part of this lesson then is taking a look at drawing horizontal and vertical lines. Now I want to examine a horizontal line, so we're going to go ahead and we're going to draw a graph over here. And here's my x-axis and here's my y-axis. And then I'm going to go ahead and I'm going to draw some random line in here. And again, sorry, you guys don't have the benefit of changing colors like I do. But here's some horizontal line. Now I want you to examine the values of x on this line. X can really be whatever you want it to be, right? We can be as far left or right as we want to. So x could be 1, 2, 3, 4. It could be -1, -2, etc. But the fact remains is that the y value is the same. Anywhere along this line, we go right, left, up, or we go left or right or whatever, but the bottom line is we always go down the exact same number of points. So for a horizontal line, the y is equal to some constant value, all right? The y is equal to some constant value, and in this case, we're going to say it's some constant c. And so for a horizontal line, the graph of y equals c is the horizontal line to the point 0c. Because no matter what the value of x is, the value of y remains constant. All right? So y is equal to c is some horizontal line. I'll change my pen color again. Let's go to something green here. And let's draw a vertical line. Here's a vertical line. Well, maybe. There. Well, again, having a little difficulty with my pen today. Sorry about that. So here's some vertical line. And as I look at that vertical line, I'm going left however many points, and then I go up, I go left and up, I go left and up, or I go left and down. The bottom line is every time I do this, I'm going to go up or down however many I want, but however much I move left to get to that line, it's always the same. And that would be the same if the line was over here as well. We go to the right, we go to the right, we go to the right. But the y value can be anything we want it to be as long as the x values for every one of those points is exactly the same. And so a vertical line will be a graph of the line that says x equals something that's constant, or it's through all the points c, 0. You know, that kind of looks like an A, but it's C. So we're going to go through all the points C0, where C is the value left or right that I go to get to my line, and I can go up and down as much as I want. So it looks a little tricky because we've talked before about the horizontal axis. The horizontal axis is the x-axis. So it's a little confusing that y equals c is a horizontal line. So it's a little counterintuitive. Again, vertical lines say x equal, even though the y-axis goes up and down. So again, whatever you need to do to help you remember that, again, the way that I think about it is a horizontal line is a collection of all the points where y stays the same. So that means our up and down doesn't change. A vertical line is all the points where the x's don't change, and so that will be x equals some constant. All right, so let's go ahead and take a look at graphing a couple of these, and I'll change back to a pen that's not quite so bold here. Graph y equals -1. And so to graph y equal -1, we're going to go ahead and we're going to say, look, the graph of y equals -1, because it says y equals a constant, it is going to be a horizontal line that passes through the point 0, -1. So here's 0, -1, and it's a horizontal line that passes through here. All right? And so there's the line y equals -1. Notice that any point on that line is down 1. The x can be whatever you want it to be. This is left 2, down 1, left 3, down 1, left 4, down 1. But the y values are constantly remaining at -1. What about a graph of x equals 2? Okay, x equals 2 is a collection of all the points where the first number is 2, like 2, 0, 2, 1, 2, 2, 2, 3, etc. And so a graph of that line looks like this. All right? Once again, I'm sorry, going back to the previous example, notice that every point on the line has a y-coordinate of -1. I kind of explained that. The graph of x equal 2 is a vertical line that passes through the point 2, 0. Notice that every point on the line has an x-coordinate of 2. All right, so I'm going to have you guys try a number of practice problems here. There are exactly 6 examples to try here. 2 of them are in slope-intercept form, 2 of them are in standard form, and then 2 are horizontal and vertical lines. So we're going to break it up into 3 separate parts. The first thing I want you to do is I want you to try the first 2 examples. All right, try the first 2 examples on your own, and then restart your video, and we'll take a look at these results. In example number 1, once again, this is already in slope-intercept form. It already says y equals mx plus b. So I identify the slope, and we identify the y-intercept. In this case, my slope is -2, and my y-intercept is 2. So that means, starting from the point 2, and again, you have to be careful about how these are labeled. Each of these spaces is counting by 2. So I'm going to start at the y-intercept of 2, and then my slope is the number -2. Now we can write that as a fraction. It's just -2 over 1. And so my ratio of rise to run is rise -2 and run 1. So from that point, I'm going to go down 2 and then over 1, remembering that they're counting by 2's here, so I'm going to only go over half a space. Down 2 over 1, down 2 over 1, down 2 over 1. We'll do that a few times, and you can see now that you're starting to develop that pattern here. All right, and right about up 2 over 1, up 2 over. Sorry, I'm just trying to get a better point to go through. Oh, I missed terribly. Let's try again. You guys use a straight edge, please. I'm having a difficult time getting that to work the way I want it to. So there we go. And so there's my collection of all the points where y equals -2x plus 2. All right. The next example is also already in slope-intercept form. Once again, pay attention to the fact that they're counting by 2's here. So my y-intercept is -4. So I'm going to start down here at -4. So there's down 2, down 4. All right. And then my slope is rise 4, run 3. So to rise 4, I'm going to go up 2 spaces. And then to run 3, I'm going to go 1, 2, 3. And there's my first point. Up 4 over 3. Up 4 over 3. And again, you guys use a straight edge, please. But you can connect your dots pretty easily. I don't have the ability to do that with my whiteboard pen here, okay? All right, so this is a collection of all the points y equals 4/3 x minus 4. Take a look at this example. Notice that this one has a slope that's negative. Okay, the slope is negative, it is less than 0, and so obviously the line falls from left to right, which is a recap from the previous lesson. This one has a positive slope, and so it goes up as we work from left to right. So making sure that those two match, it's a good way to check. All right, so go ahead and pause your video, try the next 2 examples, and we'll come back and we'll go over those. The next 2 examples are not written in slope-intercept form. They do not say y equals mx plus b. So you can't simply say the number before x is the slope. That doesn't work in this example. All right? So because these are in standard form, we're going to go ahead and graph these by using the intercepts. So to find the x-intercept, we know that when the x-intercept happens, y is equal to 0. So we're going to rewrite the equation. 4x plus 2 times y equals 8. This cancels out, and so when I divide both sides by 4, I get x equals 2. So my x-intercept is right there at 2. Okay? To find the y-intercept, I know that x is equal to 0. And so I'm going to write 4 times x plus 2 times y is equal to 8. 4 times 0 is going to cancel, so divide by 2, and I get y is equal to 4. And so there is the point 0, 4. So I've got the point 2, 0, and I've got the point 0, 4, and now I'm going to go ahead and connect those two with a straight line. And once again, you guys use a straight edge. I have a little difficult time doing that, but that's basically what your line looks like. All right, for the next example, to find the x-intercept, the x-intercept happens when y equals 0. So I'm going to substitute in a 0 for y and rewrite the equation. 5x plus 3 times 0 equals 15. And again, 3 times 0 is going to be gone. And so now I'm going to divide both sides by -5. Make sure you're not adding 5 here. And x equals -3. So my x-intercept is at -3. Again, they're counting by 2's here. So there's 2, there's 4. So right in there is going to be the point -3, 0. To find the y-intercept, I know that's when x is equal to 0. So I'm going to rewrite the equation. -5 times 0 plus 3y is equal to 15. This is gone. Divide both sides by 3, and y equals 5. And so that's the point 0, 5. And so we're going to go ahead and plot that as well. There's 2, 4, 6, and so there would be 5 right there. And we're going to go ahead and connect those two with a line. Okay, pause your video, try the last 2 examples, and we'll come back and recap and finish this thing up. Okay, so the last one here has y equal 4. Again, all the y values are staying at 4. So that means I'm constantly going to be up 4. So here's the point 0, 4, here's the point 2, 4, here's 4, 4, here's 6, 4, here's 8, 4, etc., etc. You guys should be getting the idea that y equals lines are horizontal lines. All right? X equals -2 is a collection of all the points that are left 2. Doesn't matter how high or low we go, as long as we go left 2. So left 2 up 0, left 2 up 2, left 2 up 4, left 2 up 6, etc., etc. Again, the first number there says go left 2, and so there is a graph of x equals -2. Notice it's a vertical line because it says x equals, and notice this one is a horizontal line because it says y equals. And again, that's counterintuitive because the vertical axis is the y-axis, so it means it's a little different, okay? But don't lose sight of the fact that it's a collection of all points where x stays the same. So that's the part that gets us our vertical line. So that concludes lesson 2.3. Hopefully that went well for you, and we will talk about your questions tomorrow.